Come on, let's go now, engineer, to the control circuit of the disconnector and earth switches. The disconnector and earth switches circuit has a lot of stories as control. I don't want you to focus on this middle part, because tomorrow during integration, something called double operation and something called long runtime will happen. Things will start to connect with each other. So I can't talk about it today until I finish the motor circuit and the control circuit. Just consider that I'm telling you there's a negative going and a positive going, a direct positive and a positive through. But, okay, where are we going? We're going to page what? Going to page 11. All right, engineer, here is page 11. This circle is the same as the one on the next page and the same as the one on the page after that, because in the end, they are all the same. So we study one and the rest are the same. All right, so where's the idea here? The idea here, engineer, is that you have a negative coming from below like this, and you have a direct positive coming from above. And there's a local or remote positive and a positive for the emergency. As usual, I bring the emergency here, come here, press select, then close or open. All right, this is the main for the disconnector switch, meaning what I'm doing here is closing or opening the disconnector switch. And the same goes for the emergency here. I press select, close, and open. For what? For the earth switch, because this is altogether a 3-position switch. What is a 3-position switch? It's either DS or ES. A 3-position switch, either DS or ES. All right, and if I'm in local or remote mode, I come here and want to stop the disconnector. There's a contact here that closes and returns the positive here. And if I want to open the disconnector, there are 2 contacts that close and return the positive here. The same applies to the earth switch. Nice. Nice. So if I give a close command or open command to the disconnector and a close command or open command to the earth switch, it will send a pulse here. It will pass through the contact, either K4A or K4B, which is done in case the interlocking is achieved. The contact, either K4A or K4B, does this in case the interlocking is achieved. The start of the interlocking, I won't talk about it today either. Consider this now as the DC continuing here normally. So the positive here comes to activate either K21, K22, K31, or K32, which we were just talking about a little while ago, right? Nice. Okay, the switches are different from the breaker. What does the breaker mean? When you press select and close the breaker, it spring releases and closes in milliseconds, 100 milliseconds. And you pressed it with your hand for 1 or 2 seconds, right? But with the switches, you press close and remove your hand, and the motor actually takes 5 seconds to close. So you pressed close and removed your hand. How will the motor continue to rotate? That's why as soon as K21 or 22 or 31 here or 32 starts, you find each one of them does a self-latch. What is a self-latch? It latches itself to keep running until it reaches the end of the journey. How does it reach the end of the journey? Look with me. The negative comes to you here from below and runs here. The first thing you find is something called the bad lock switch. This bad lock switch is a key located inside the box of the knife itself, as you can see inside your dotted box, and inside it there is a key. This key is used for lock and operate. Remember the motor of the circuit breaker lock and operate? But the motor of the circuit breaker lock and operate was located in the cell of the earth switch. However, this key is inside the knife itself, inside the mechanism box. You lock it, remove the key, and put it in your pocket. No one can tamper with this disconnector or the earth switch, neither electrically, mechanically, nor manually, and no one can come near it. All right, that's good. Okay, so here you will make it operate to bring the negative here. Here the door switch must be closed, so the door switch will allow you electrical movement. We said the door, meaning its natural drawing, is depicted in the open position. That's why when you close the door, it allows you flexibility. Here you have something called LSA and something called LSB. What are these? These are limit switches. Let's see together what a limit switch does. We are now talking about LSA and LSB, which are our limit switches. Now you have the 3-position switch. Let me draw it for you in a practical way, like when I tell you here the DS is closed and here the ES is closed. And here, and the S is closed. And here the knife switch is fully open. Fully open means it is neither DS closed nor ES closed, or let's say it is off. Is that clear, engineer? Very good, excellent. So who are the LSA and LSP? Initially, I want you to always imagine something very important. Let me do another demonstration so that the topic is clear in front of you. Of course, I see that the camera is probably small. So what will I do? I'll zoom in like this. I think the drawing is clear now, right? Both are clear together, correct? Can someone just reply to me in the chat? What should we do? Someone needs to respond to us. I'm actually scared. It's better if my voice isn't coming out at all. Where is the chat? Why isn't the chat showing up? Oh, it's our turn here. Okay, fine, excellent. All right, let's understand now. The LSL that you see here in this diagram, isn't it responsible for connecting the negative here so that I can close the disconnector? You told me yes. And it's also responsible for connecting the negative here so that I can close the earth switch. You told me yes. Yes, does that mean that this LSA must be closed so that I can close the disconnector and I can close the earth switch? This means that for the LSA, it is closed in this entire area. Up to here and the limit here and here in this entire area, the LSA is closed, meaning this limit switch is closed as long as you are here in the middle of the path. Anywhere except when the DS is closed or the ES is closed. When the DS is closed or the ES is closed, the LSA is open. And at here, and the LSA is open here, meaning this limit switch opens in two cases. Either you have reached the end of the disconnector's path or you have reached the end of the earth switch's path. Okay? And the LSP allows the negative to pass so I can open the disconnector or I can open the earth switch. Right? Very good. So this means that it is supposed to be closed from here to here and from here to here only. So this part and this part, the LSP is closed, meaning it is completely closed until where? Until you reach the fully open position, then the LSP is open. Is that clear, engineer? Very good. So what does this mean? It means that your LSA is closed. And therefore, when you reach the emergency, you press select and then close. Here, the look is achieved. K21 is activated, receiving a negative from below the padlock switch, which has been upgraded. The door is closed, and here the limit switch is closed. So K21 is activated, latching itself, and then it closes the circuit in the motor area. The motor runs until it reaches the end of its path, and the LSA opens. As soon as the LSA opens, T21 resets as if nothing happened, and everything is fine here. Now a question. Why does the LSA need to be closed in all this area, except here and here? It's because, God forbid, if the power goes out and the switch is in the middle of its path and then the power comes back on at the station for any reason, you need to have both LSA and LSB closed so that you can continue your operation either in the closing direction or the opening direction, meaning you are in the middle of the path. Both need to be closed so that if the total circuit is cut off and the switch is in this part, in this part, in this part, in the middle of the path, and the power comes back on, you have the ability to continue. In your operation, you were closing the disconnector, and stopped here. When the power returned, you might say, I don't want to close it anymore. I want to open it. If it stopped in the middle of the path here, you are allowed to open or close it. Therefore, LSB and LSA must be connected to your negative A, the negative from below. So, engineers, this is the very detailed story of the control here. Now let's move on to another very important part indeed. Let me bring our camera. As you can see, the handle is not significant. All right, let's move on to another part. So he said, okay, now I'm going to work on this knife manually. I'm the one who will close it. So I opened the door and entered the room. Should I turn right or left? There's a diagram in front of you showing you to turn right and left, and it has the instructions for the closing and opening of the disconnector and the air solenoid. All right, I forgot I was supposed to close the disconnector, and when I went to close the earth switch, I caused a short circuit, right? Am I wrong? Right, correct. I told you, no, I'm going to do something a bit more advanced. What is this slightly advanced thing? I absolutely must. I must ensure that I have chosen or that I know what I'm going to do before I go. So he told him, all right, now for you to close manually, it means you are present in the building inside coming as an S. The first thing is that the control mode must be in what position? In the emergency position. In what position? The emergency. So you see this emergency. It comes to you here like this. Its poster comes to you here. All right. To close the disconnector or close the air switch, your interlock here must be achieved for the disconnector, or the interlock must be achieved for the air switch. You come down here. And you have a selector switch specific to the DS and the ES. It asks you, DS manual or ES manual, which one do you choose to operate? I say, well, I need the DS manual. When you select DS manual, contact 1 and 2 close and 3 and 4 open, and 2 close and 3 and 4 open. It comes to you here. Is the door open? No, the door is not open. So go ahead and open the door. As soon as you open the door, there is a solenoid here that activates called LSI LMD. You have a locking magnet specific to the disconnector that releases what? It releases outward, allowing this to unlock the gear of the motor, permitting the motor to do what? To rotate, which is the LSI LMD and LSI LME, all right? Well, the videos are a bit long because I filmed them at the station itself. So I will also try, you see this is 418 MB, I will try to upload it for you on WeTransfer, all right? Look, I want to show you LSA and LSB. Let me just share it with sound.
I was feeling unwell at the time, so you might hear my voice sounding a bit strange.
Kevin is here with me, and here I have, all right.
Which is for the disconnector. Oh, this is the shape of the magnet. What is the shape of the magnet for? The whole thing is simply because it was for a procedure. I need this now as a reposition switch. So if the operator comes out, grabs the handle, and starts to turn the knife, he might actually come out to unfold the disconnector and turn it in the wrong direction, which would unfold the switch and cause a short circuit on my bus bar. Therefore, to prevent this human error during operation, I insisted that first he must choose a specific position for the manual operation process. They will turn to open the disconnector, they will turn to open the earth switch. If he chooses the disconnector position, I will find that the solenoid here has activated, and as you can see here, there is a wire-like component that will remove a lock from in front of the gear, which allows me to rotate in the direction of either closing or opening the disconnector. The same applies to the earth switch, but it's not just about choosing the earth switch or the disconnector and then giving them the solenoid.
They connect this to work and move away.
As they observe from in front of the motor, and I can trade easily no, because I still have a problem where I might choose the disconnector, when in fact I am supposed to open the disconnector in the earth switch. Therefore, I ensure that updating the solenoids is not just about choosing the update, but the interlocking must be achieved. So now, if the interlock is achieved, plus I have chosen the DS or ES position, plus the door switch must be open, meaning the door here must be open, because here, with the door open, I always have 3 limit switches, one of which is related to the shorting that happens. Are you French guys seeing this switch? You can actually hear the video sound, right? Or am I mistaken? French guys, you know you can hear the video sound, right? Or am I mistaken? Can someone just send me a confirmation? Yes, engineer, you said it correctly. Okay, great. Do you see that switch inside? That's the lock and operate switch I mentioned to you. All right, let's continue. We connect to the motor to perform fast stopping of the motor. There is a limit switch that cuts the electrical path, and there is a limit switch that connects the manual path. So naturally, as long as I'm working with manual operation, I must open the manual path. Here, it explains the steps for manual operation. How long has it been telling you how to rotate, sanctify every black electronic, what do you eat, or whether what operation Opal? Is that okay? So now I have actually opened the door and the interlock is verified. One thing remains, which is to choose manual operation for the DS or the DS. If, for example, I choose manual operation, now I have a colleague standing by the panel. He will select the DS position for me so you can see it with me. Manual operation for the DS, this is exactly the support I have. It worked and pulled the wire, which is the metal wire, and thus opened the wire in front of the gear so that I can rotate in which direction. The disconnector, and this is the same thing. Of course, both are fine like that, engineer. So now you can, through this movement, ensure that the interlocking magnet is correctly chosen. Now the issue with the interlocking magnet is something like this. It's exactly like if you have a building and you hire security for it. So you tell the security, by God, you must check every person coming in to ensure they live in the building. He sees you yourself, and when you enter, he tells you, come here, you too, show your papers. Right or wrong? So the interlocking magnet you have installed ensures that the motor doesn't turn unless you choose the correct setting. Right or wrong? Exactly. So now if you work with the electrical system, the interlocking magnet is locked on the motor. What will you do? That's why you'll find that the interlocking magnet has a way to operate, which is through your selection under the emergency mode. It also has another operation when you give the electrical command to the disconnector or air switch through K21, K22, K31 or K32. They themselves come to operate the same interlocking magnet to remove it from their path and let the motor start to turn. This leads me to the part about K1M that I told you about. The idea now is that as soon as you give a close command to the disconnector with K1, what happens? It closes here. Here, and this contactor closes here. If I had let the positive go directly to the motor and the negative come from here directly to the motor quickly, the motor would turn at the same time. This interlocking magnet would be pulled. If this motor turns, and of course this is a DC series motor with high torque, it might damage the solenoid before it is removed from in front of the gear. That's why I wanted to create a delay before the motor turns. So what did I do? I let K21 go and activate K1M first by bringing it positive from below here and negative from above here. So when K1M was activated, it closed here and closed here, allowing the motor to run. Thus, K1M acts as a delay for the motor's rotation until the interlocking magnet relay is activated. Of course, its pickup time is a bit longer than the interlocking magnet to ensure, as I mentioned, a delay in my timing.